Let's look at section 5.4, functions defined by powers and roots. So whenever we're talking about roots, we see a radical symbol. In this case, we're just using a general root, n. Remember, the root n, it can be rewritten as a fractional exponent where the root n goes on the denominator. The numerator will be the normal exponent, which in this case is kind of hard to see, but it's a hidden 1, which is why you have a 1 on top of your fraction here. But again, the reminder is that the root always goes on the bottom of your fractional exponent. So, for instance, if you had a square root, we can rewrite that as x to a fractional exponent. Remember that a square root means the type of root you have is a 2, a root of 2, which means the 2 will go on the bottom. What's on top will be a hidden 1 because it's understood that x has a hidden exponent of 1. Let's look at a couple examples where we can rewrite these fractional exponents into radicals. Remember, radicals are just a fancy term for roots. So we have the fractional exponent and we're trying to figure out what kind of root they will turn into. Notice on this first problem that we have a 2 on the denominator, which means that this will turn into a, what type of root? A square root. Remember, if it's a square root, we do not have to write the 2. The question is square root of what? Well, we've got a 26. Technically, we can write it to the first power, but remember, if something has an exponent of 1, you don't actually have to write it. So our final answer is just as it appears. It is the square root of 26. In the next problem, in B, notice that the root is, again, whatever's on the denominator of the fractional exponent, which here is a 7. That means we're going to end up writing this as a 7th root of, well, our value in this particular problem is a 13. And again, technically it's 13 to the first power, but you don't actually have to write that. So we'll leave it as the 7th root of 13. Continuing right along, if we look at C and D here, notice they look very similar. Both of them look like we've got 81 to the 1/4 power. Notice, however, one has parentheses and one does not. So on one of these, the negative sign that's attached to the 81 will be inside of the 4th root, and on the other it will be on the outside of the 4th root. Which one is which? Well, notice that D has parentheses around the negative, which means that the negative will be on the inside of your, in this case, it's a 4th root. So we'll rewrite our 4th root with the 81 on the negative 81 on the inside because it's inside of the parentheses. Whereas the other 4th root here on problem C does not have parentheses, so it's understood that the only thing that's inside of that 4th root is the 81 itself, which means that that negative sign, because of the fact that there are no parentheses here, is on the outside of the entire root. Well, this means that one of these has an answer and one of these does not. Well, on the first one, it's asking for us to do the root first. So it's asking what number multiplied by itself 4 times will give us 81. And then we will put the negative sign on at the end because it's on the outside. Well, what number multiplied by itself 4 times is 81? Well, that is the number 3. And again, we'll just put the negative on at the very end because it was out in front. Whereas on D, we have a negative on the inside. So this is now asking, what multiplied by itself 4 times gives us a negative 81? Well, if you multiply anything by itself 4 times, whether it's positive or negative, it will still be a positive answer. So this is not possible, at least not yet. So we're going to give a kind of vague answer of that the answer is not a real number. So in conclusion, the one where the negative sign is on the outside of an even root, we can get an answer, whereas if the negative is on the inside of the root, we couldn't because it was an even root. Had they both been odd roots in C and D, it would not have mattered at all. We would have been able to get an answer in both C and D had they been odd roots.